Good morning, Michael. Here
morning,
we
Matt.
have a new subject related to what we've done previously. So Taylor polynomial. Let's have a look at our friend the cosine again.
Yeah, we'll do the cosine function because we've seen from graphically how we can approximate the cosine with a nice polynomial.
Yep.
Now, the trick to Taylor polynomials is you say, what polynomial do I want to use? Well, the one you should use is the one that has its derivatives matching the derivatives of cosine at a point.
Let's have a look at 0, x equals 0.
Yeah, so let's do a little chart here. I'm going to write down a function and its derivative and its second derivative. And we can use this notation for third derivative and fourth derivative. Okay, so here's a cosine function. And then here's the function. Let's do the fourth order one, this guy here, and see how well this works. So 1 minus a half x squared plus 1 over 24 x to the fourth. Now, Matt, I get to quiz you. What's the derivative of cosine?
Minus sine.
Minus sine.
Yeah, so you know what? A lot of students forget whether it's plus sign or minus sign for this.
Yeah.
Think of a roller coaster. You're at the top of the roller coaster. Where are you going to go right away? Down.
Down. There you go. So negative.
Yep.
Derivative of negative sine.
Negative cos.
Negative cos.
Well, now we just rinse and repeat with the extra minus sign.
So this is going to come out as a positive sign. And this will come out as a positive cosine. Now, how about this guy? Differentiate 1, I get
0.
So I'm not going to write it down. Differentiate this guy.
I get
2 comes over here.
2x times minus a half. So that's minus x.
And then I differentiate this guy.
It'll
be
4x plus 4x cubed times divided by 24.
So 4 over 24, I don't want to write that down.
A sixth.
Right. Differentiate this. I'll do this one quickly because I'm feeling happy. Differentiate this. What do I get? Derivative of minus 1 is
0.
So I won't write it down.
Half.
So this here I get a half. Oh, I missed something.
Yep.
Good thing we're checking. Okay, and now differentiate that in 0, and the 2 comes over, and I'm left with an x. And the derivative of x is
1.
1. Now, let's evaluate this at 0, right? We want to check at x equals 0. This number is, sine of 0 is?
0. That's 0, and that's 0. So those...
They equal at 0.
Okay, next one.
S at
X equals 0.
minus cosine of 0 is?
Minus 1.
So this is minus 1.
And the other one is 0 at x equals 0.
Minus 1 plus 0 is minus 1. So these two are equal. They're equal to minus 1, right?
Right.
Sine of 0 is?
0.
Which is 0.
0.
So these guys are equal.
And
Cosine of 0?
is 1.
So these are both 1.
So all the derivatives match.
They all match. And that's the secret.
Equals, equal to 0.
Exactly, yeah. Now, we even know more than that. And this is a little bit more than we can do in a quick video. But there's going to be an error term.
Yeah, we can see it. Go back to your graph. You see that there's an error term, right?
Mm-hmm. So there's a little, I'm going to draw here, like here is my nice fourth order polynomial. You see there's a gap between the two. So if we measure the distance between the actual cosine function, which is this pink guy, and the polynomial, so this is the function, well, okay, it's a cosine of x, and we subtract off this polynomial. This gives us, some people call it the remainder term, or you can think of it as an error term. Turns out that this is small. And we can actually say how small.
If we use?
The mean value theorem.
Oh, okay.
So this comes out of the mean value theorem. What we can get immediately from the mean value theorem is this is always less than x. I'm going to put it in absolute values. X raised to the power 5, okay, divided by 5 factorial.
Could it be 6? N plus 1? Oh, no, you got
No,
N
it's
plus
starting
1.
with 4.
4,
Yeah, we
so
went up to
that's
4.
right. 5
Yeah.
is right.
And then here, it will be the fifth derivative of cosine, I'm going to write it as f, at some intermediate point c, just like we had in the mean value theorem.
And C is between 0 and
And
X?
1.
Or
Well, for the cosine, of course, yeah, c is between 0 and x. So here's 0, here's x, and c is somewhere in between. We don't know what the c is, but if we know this derivative is bounded, so for instance, with the cosine functions, all its derivatives are bounded by 1. This is smaller than 1. This is smaller than x to the 5th power, divided by 5 factorial, which is
and
120.
X is going to be close to 0, so C will be between those two numbers. Where we're
Right.
picking the point to evaluate our approximation to cosine. So there it is.
So there we go. So this is how much error we can expect. No more than that. And so if x is small, like 0.1, this is 0.000001, a very small number, divided by 120, which gives me a couple more decimal places of accuracy.
So we'll see how we actually get to this point next time.
Next time. Thank you, Matthew.
Thank you.